We are starting our session. So this is multipathing uh, SlideShare which I've downloaded from slideshare.com, and somebody has compiled this very well. So I will be taking this as a reference to guide you through the multipathing actually in Linux. But multipathing concept is everywhere in our infra environment, starting from switch, storage, and to OS level and to the application level. So we will try to take reference of Linux, and then we will try to map it to the other technologies as well. So moving forward, so this is compiled by Anand, and we want to thank him. So we are using his slide as a reference. So what exactly is multipathing? Device mapper is DM. Device mapper is just the utility which is used to configure the multipath in Linux. But before going into analysis of device mapper, we should concentrate on what is multipath. So multipath is when I'm having a switch, and then I'm having a router, then I'm having an OS, then I'm having a storage. I'm connecting through a a network path between all of them. But if I want a redundancy in that network path, if I want a redundancy in their connectivity, so it's an ideal to have a multi-path between them, so that if we lose a connectivity on one path, we can like we can like carry on with our task on other path. It is very useful when we are patching things, when we are upgrading things, so we can fail over our environment to other paths, and then we can just carry on our patching on the path which we want to do it. So multipath is configured using multipath utility in Linux and device mapper utility. So first we will be going to call it as a definitive property, which allow you to configure multiple IO paths between server nodes and storage array into a single device. You can also take it as an example. I have a server A. It is connected to a storage EMC1. Then I have a server B. It is connected to a storage EMC1. So if I want to patch my EMC controller, and I have only one path between them, so I need an outage, I need a downtime to patch it. But if I configure multipath on my SAN side, then be a uh, it will be a thing of just failovering the everything onto a second path and patching the controller. So multipath aggregates the IO paths, creating a new device that consists of aggregated paths. But there should be some utility on your server side which should understand the multipath. It should make your application, make your kernel understood that okay, I have these two paths which are multipath. Don't be confused. Don't try to use both of these paths at a time. You need to use this path at this particular time, and then this path at this particular time. So there should be a utility which should make your kernel understood the concept of multipathing. So that utility is device mapper in Linux. So moving on to it, DM is used to provide, that we already told. Either we can use it to provide redundancy, or we can use it to provide an improved performance. How improved performance? We can use multipath as load balancer. Okay, we can use multipath as fault tolerance, right? So if you are using it as a load balancer, then it will actually improve your performances. If I can place a multipath and use it as a round robin fashion, then I can distribute my heads among my servers of same application, but I can increase the performances because now you can manage the load on your application. And how it is using for redundancy, if they are active passive configuration. So my one server is working, and my one server, I have one path, I have one IP, and which is active, which is, and second is passive. In case of failure, I can switch on to my passive path. But this all is defined how your DM path is configured. In few environments, it is only configured to give redundancy. In few environments, it is configured to give improved performances, right? So if you have any questions, just ping those questions in chat. I can try to answer them uh, side by side. Okay. So moving on to so now this is active passive multipath configuration. So if you see, I have a one RAID device. RAID device. That RAID device is attached to two controllers. So my two controllers are managing the one RAID device. RAID, you can say it is a storage, right? So that RAID is an array which is managed by two controllers, which is connected to two SANs. SAN is my storage area network, and then that SAN is connected to my HBA of server. Now to access that RAID to server, I have actually two paths. If you see, HBA1 SAN1 controller 1, HBA2 SAN2 controller 2. So in case my HBA1 fails, or I need to do any maintenance on SAN1 or controller 1, then I can shift my all traffic to HBA2 SAN2 controller 2. So this is multipath configuration in active passive mode. In this case, you can't use both paths simultaneously. There is no probability of failover between SAN and SAN, but you can have a whole set of different bunch of paths which can be used in case of failure. So this is one type of multipathing. Any questions? No. So moving on to, so this is my active passive multipathing with two RAID devices. Now I have two filers with two controllers with SAN and HB1. Now I have two filers which are actually having the sync between them. Now my probability at filer level increases. Now if I want to patch the SAN2, I have one path which is going to RAID A and second path which is going to RAID B. I can easily fail over my controller 2 anywhere on in RAID 1 or RAID A or B. So now my redundancy at RAID level increased. So now my probability of failover also increased. So anybody from storage who want to patch SAN, they can easily fail over from controller 2 on RAID B to controller 2 on RAID A, and then they can patch SAN2. So there is no downtime at SAN level. At first there was no downtime at server level. Now active passive, even you avoid the downtime at SAN level because now you are using the two RAID devices. Got it? So this is active. So active means I have a common SAN which will have two paths to your storage, but those two paths will be active. So if your one hit will come to HBA1, it can be moved to controller 2 as well or controller 1 as well. There is no different separate path. But in this case, if you want to patch SAN, then you need an outage. But if you want to patch storage, just move your all controllers to controller 1 and then you can patch controller 2. In the same way you can patch controller 1 by failovering the everything to controller 2. Same thing happen on server side. If you but here there is one important thing which we need to take care. If you are using any UCS or any HP as a base, you can't configure server on multipath. You need to configure it on a single path, then you need to put the settings of multipath, right? Because if you try to configure server on multipath, your OS disk will be confused from where I need to get my OS, right? So this is very genuine mistake which I have seen in my environment. People generally try to do multipathing first and then try to boot the server. You need to configure server on single path, then configure it on a multipathing. I know this is not related to topic, but this can be very crucial. So now moving to now this slide actually told you the logic which we are using at system level to configure the multipathing. So without DM multipath, each path from the server node to the storage controller is treated by the system as a separate device. Even with the I/O path connected to same server node to same storage, DM path provides a way of organizing the input-output path logically by creating a single multipath device on the top of underlying devices. So the thing which I was trying to convince you in starting of my presentation, that DM multipath is actually the utility which will tell your kernel that actually I have logical distribution of paths, so you need to understand that logical distribution. So it will provide WWID to each multipath device, and granted that WWID should remain globally unique and unchanging. By default, the name of multipath device is set to WWID. So it will try to provide that kernel will reboot, your WWID number will remain unique, so that kernel and OS can easily understand it. So any questions till now? Okay, that's fine. Now here is a very good example of multipathing. For example, a node with two HBA is attached to storage with two ports via single unzoned FC. Okay, before starting, I need to tell you one thing. You need to define a zoning in order to do multipathing. Zoning is a path which is being provided by network to your storage, which that it should only see this specific set of WWIN number, then they so that it shouldn't broadcast everything. So that is a zoning. So now I have SDA1, SDB, SDC, SDD. These are four disks, and DM path create a single device of unique WWID number and reroutes IOs to four underlying devices according to multipath configuration. When user-friendly names are set to yes, the multipath device is set to mpathn. So what that will do? It will create a unique ID, a UUID number for every SD you have attached to your system. Now that SD is been provided a user path, mpath1, mpath2, mpath, or it can define a DM1, DM2, DM3, DM4. So every disk you add, multipath will give it a UUID number and provide it a DM number. So with the DM number, your OS can easily recognize that my this disk is multipath, so I need to use this path in case of failure. So that devices are defined in dev mapper created early in a boot process. Whenever you boot the system, those devices are created in a dev mapper file, and dev mpath are provided as a convenience so that all multipath devices can be seen in a one directory. So as a user, if I want to see all the multipath devices, I need to go as device mpath. So if I ls in that, I will see all the volumes, all the logical file systems which are defined as mpath, right? So multipathing is really a easy concept when we see it on a diagram, but when we see it as a configuration, it may confuse you, but you need to understand what terminologies DM provides so that we can easily recognize it, right? So DM will actually change your SDA, SDB, SDC into the dev mapper path, so that dev mapper paths are stored in mpath. So these are my DM multipath components. So first is DM multipath. Whenever you install DM multipath, there is a kernel module which will reroute your input output to support the failover. Install any utility, there is a module for kernel which will communicate between your bash and your OS. That path. I'm having a multipathing, that is multipath-ll. If you run that command on your OS, if you see multiple paths, multiple DM paths, that will confirm you that your multipathing is configured on your system, right? So this is all Linux logic, but I just want to make you understand the what actually multipathing is. So that was my. So how you set the multipath? There is an RPM for it. Just install that RPM, then you can edit the multipath.conf. So you can actually blacklist the default devices. You can actually change what type of protocol you want to use, what type of algorithm. Is it round robin? Is it highest priority first? It is lowest priority first? It is failover? Everything you can define in your multipath.conf. So if you want to check what type of rerouting is being supported in your multipath device, just go to etcmultipath.conf and you will check each and every settings in it. So this is here is my file. So you can define configuration, file overview, blacklist, default, multipath, and file devices. So it is very easy in Linux. Everything is defined. Everything is file level. You can just go into a file and check your configuration, right? So what is blacklist? So blacklist is listing of specific devices that will not be considered as multipath. You don't want your root device to be multipath. You don't want your boot device to be multipath. Just put that devices in blacklist, right? So what is multipath? Setting the characteristic of individual part devices. These values override what is specified in default and devices. So every vendor has its generic format or defining the multipathing. So you need to get that generic format and you need to get the default rule which they want to use. Like Dell may have their generic format, Hitachi may have their generic format, IBM may have. So you need to go to their site and try to find out what type of IO, what type of service they use during multipath and just use that setting into multipath.com. Sometimes what we do, we try to copy the multipath of because of second storage. Then what happen? It will not work because you have copied it from NetApp to EMC. So NetApp may has its own way of talking to multipath, right? So any questions?
What will happen if we can't blacklist the things that boot thing and anything?
That because your boot path is coming only from one path. So if you don't blacklist it, when you reboot the server, your server will be confused that from which path I need to get the boot, because whenever you boot the thing, it will use LAN ID 1 and that LAN ID will contain your boot image. So if your boot image is also multipath, your OS will not able to recognize from where I need to pick that image, right? So but when your boot is successful, then your M paths are created, your dev mapper is created, then everything is created there. Then you can easily recognize that okay, then your OS start easily recognizing that okay, this disk is multipath, this, but initially when you are booting the things, your OS will never recognize, right?
So this configured on the storage side or the server side?
No, they are multipath is configured on server side, but if I talk about storage and tape, then it can be configured on storage side as well. So I'm taking the reference of server side only.
Okay.
So this is like configuring the blacklist. So how to configure the blacklist? So either you can blacklist using WWID number or your device name or your device type. So you can choose to blacklist your device, right? So multipath configuration file defaults. So what are the default things which come in when you first install your multipath.conf that we will be covering. Multipath attributes. So this slide is moving more towards the configuration of multipath, but when you are moving to the configuration of multipath, you will get to know the multipath concept more. You can have more deep dive into it, right? So default attributes will have an sample example, and default attributes will have a sample example from each vendor. So you need to using the storage of this vendor. So I need to use the multipath attributes for these vendors. So these are my attributes. Just uncomment those and put your unique WWID number and configure it. And when you will restart your multipath.conf, you shouldn't be getting any errors. If you are getting any errors, this means either you are not configuring it properly, or your DM paths are not configured properly, or it will again add the boot level and create your new DM paths, right? So I think this will move to slide number 17. So these are the options which you can use with command. If you're using multipath-l, it will display the current multipath configuration gathered with from sysfc and device mapper. So what you are currently using as a configuration, you want to check your configuration, just use multipath-l. if you want if you want to check the configuration from all available devices, then you just need to give -ll. If you want to check from present, use 1l. If you want to check all the devices, use double L. And if you want to multipath-f and give the device name, device id, it will remove it. If you want to remove all multipath devices, multipath-f, bade wala, big F. So it will like we are using ip table -f, right? It will flush everything. So same thing you can use. So another command which can be used to find the device mapper and entries in multipath is dm setup. So if I'm talking about if config, there is setup command also to use the ip table configuration. In the same way, we have another command which is for multipath, right? So we also have a multipath interactive console, which is known as multipath-k, which will give you a multipath interactive. It is like a terminal TLI. So you can actually go through the multipath, which disk has been attached with which disk has the multipath. But if you want to make your environment redundant, that ensure that every server in your environment is running on multipath. So what I have done almost is a very big concept. I have just taken it through the Linux prospect, and I just want to make you an overview of multipath, how it helps. But multipathing is used in every level of infra now: storage, network, and then your server level, then your application level.